P.V. Prasad joins us as a panelist. He's a veteran in managing engineering, heavy construction and power projects, having more than 3 decades of extensive experience in the power and shipping sector, of which 22 years have been dedicated to RE. Our next esteemed panelist, Mr. Mahesh Moni, the Head Electrical Engineering at Nordex India Engineering Center. Once again, more than 2 decades of experience in the wind energy. He has had a very progressive stints along the entire supply chain of wind electro-related components, ranging from product development, procurement, testing, and the manufacturing to OMS. Inviting now Mr. Sivashankar Kasturi, the OEM manager for the Asia Pacific region for industrial lubricants with Shell Global Lubricants, diversified experience of more than 25 years in maintenance, operations and TCO approaches from lubrication perspective. His areas of specialization include all major industrial lubricant portfolio and critical applications. And now we have Mr. Alphonse Boeing, the head of the development department for new technologies for wind turbine gearboxes at Flinders Windenergy. Inviting now our moderator of the session, Dr. Chakradhar Byreddy, Director Renewables, UL Solutions, Asia Pacific, Middle East and Africa. He leads the testing, inspection, certification, advisory operations and its service expansion in the wind, solar and battery storage industry. Also drives the UL Solutions efforts for stakeholder engagement in the renewable energy space, including various government, ministries, regulators and industry association. So we take this discussion on technology innovation. I request our moderator, Mr. Chakradhar Byreddy.
Thank you so much. I think it's quite exciting to see good audience over here. Good afternoon, everyone. It's very, very important that we talk about this particular topic of innovation and technology, because that's what drives, at the end of the day, some of the projects on the ground. I think I would like to focus the session in 2 folds. We'll talk about onshore wind. I would also like to bring about offshore wind too. So let me start with RPV, the CEO of Envision. What do you guys are planning in the next couple of years as part of your roadmap in terms of technology and innovation and bringing out new products into the market? And what would be your criteria in bringing those products? Is it the hub height, rotor diameter, rated power? I mean, is it capex per kilowatt hour? What drives it? And what is the basis in your judgment?
Thank you, Chakradhar. Yeah, it's first, it's a good question. What is the criteria to bring an innovation? How you can bring the new technology and new turbines, as both in onshore and offshore. If you see, yes, we have as a company, we have a lot of internal innovation centers. Even India also we consider center of excellence, because India has a lot of talent is there. So we are developing as a center of excellence in India, and this team will be support to across the globe. So with this support, we have a lot of ideas to bring the new technology. As a company, we have up to in on ground, we have up to 10 megawatts. We have a turbines on onshore. On offshore, we have 14 megawatt. We have turbine. But coming to the challenge to bring to India, what is the criteria? Yes, as you rightly mentioned, at present we have a 3.3 megawatt of turbine. That is of the 156 rotor. We are readily available of the 171 rotor dia, of the again around it will be megawatt will be 4.8 something. But we are facing challenges on the different area on the innovation wise and technology wise. We are ready with the gate up. Of course, we are working on a lot of other challenges in India to logistics point of view that we'll do. Coming to the main criteria, we have to see cost of energy. That is the main, it will going to be drive, because in India, very cost sensitive. So that's what we are trying to make what is the cost of energy best fit for in India. We are trying to bring this. And coming to the offshore, we have already 8.5 megawatt of 226 rotor. That we'll feel that 226 is the right rotor dia, because that logistics point of view, we have huge challenges. And infrastructure of the India, like offshore, like all the ports, whether it will be ready. And we have to see that how we can able to, offshore, if we want to start the manufacturing in India, we have to see it is to be near to the shore. Because sea logistics is going to become a more challenge, and sea logistics is going to be taking more importance for that. And technology-wise, if it is near to the offshore, or near to the shore, that will be near to the, so that we can bring the technology, we can bring the turbines so that we can reduce the cost of the logistics. And cost-wise, even coming to the, just I want to add little, this one, blade. For example, now we have started our own blade plant in Trichy. Technology-wise, we are putting a lot of efforts to be how to improve the process. For example, in our blade plant, we are putting each mole of 19 artificial cameras, AI cameras, that will study the each motion and time study. And it will be helpful for the how we can able to improve the process. So with this process improvement, how we can able to get the benefit, and we can reduce the cycle time so that we can give the automatic process. Cycle time is reduced. Of course, it will impact to the, it will reduce the cost of the blade also. So we are trying in all the efforts to bring the new technology, and how can bring the cost is going to be reduced. So these are the efforts we are bringing into the industry. Thank you.
I mean, thanks for giving that insight, and probably you went a little bit deep far into the offshore too. Having said that, Alphonse, I think a lot of focus on the innovation and technology is always on CapEx. But what do you see from your point of view, that why should we focus on the OpEx side of those costs as well?
Yeah, thank you for raising the question. From our point of view, CapEx is really an important topic. So we also want to support our customers in doing the best to improve or decrease the CapEx. But OpEx is also a very important topic in the long-term perspective, and we are supporting this in providing reliable products, that we decrease service amounts, that we decrease those operating costs in that way, that we really provide reliable products into the market. And I think that is our contribution as a component supplier. So we are supplying gearboxes, couplings, generators, generator elements for direct drives. So we have a wide spread of products we provide to the market, and we are looking for innovations which contribute to that. So on the CapEx side, for sure, we are looking for innovations which drive down the overall cost. That means that we are looking for technologies which increase the power density itself. This contributes to the product itself, to the components themselves, to the costs we create by that. But this is also a contribution we have to sustainability. So we are using the material in a better way. We utilize the used material in a higher share, and by that, I think this is also a contribution we are providing to sustainability. Yeah? So there are a lot of technologies which are also helping our customers, the OEMs, to decrease sizes, decrease tower masses. By that, also other components can be downsized and can create additional potential, not only in the on the component level at our side, but also on the customer side.
Yeah, thank you, Alfonso. I think that was a great insight in terms of providing the visibility of the innovation that you guys are doing on the OpEx side. So I would like to now go to Mahesh. Sorry, Shiva. The question is, I think we spoke prior to this discussion, that standardization of plug-and-play approach, would it help the industry, and what are the views of what you think, whether it is stifle the innovation, and what are the reasons why where we are? Because one of the big issues is we are always compared with the automotive industry, and they said that they are much more modular in the way they operate their supply chain. What is your view on that?
Thank you, Chair. So I think before I respond to that, I quickly wanted to have a quick reflection on the point raised by Alphonse. Primarily on OPEX, and typically in an independent research done about 4 years back in US, on average, we have close to about 1,200 gearbox, 1,200 gearbox failures a year. Now, gearbox failures includes a lot of generator failures as well. Now, coming back to the question, typically when we are discussing about this, on an average, the wind industry spends about $8 billion on an annual basis in terms of failures. It could be failures of components, it could be failures of blades or generators or whatever it is. Now, the question is then, now coming back to your question, so what exactly is the idea of, innovation or standardization? Because I personally feel standardization and innovation are paradox to each other, because I think the moment I have some standardization, I can never think of innovation, because the three pillars which primarily drive reliability are innovation, application, and partnership. So the more and more, for example, as one of the largest oil and gas major, we feel that our responsibility is to innovate new molecules, which are there primarily to reduce the friction, improve the tribological properties and efficiency of the drives or generators or blade bearings, whatever. And then how do we kind of partner with our OEMs, with our asset owners, or how do you say, wind turbine partners, etc., in terms of building more awareness in terms of maintenance practices, partnership, and then application practices. So possibly, I think if we look back to the industry, not necessarily wind industry, but in general, it could be the general industrial applications. The size of a gearbox, the size of a 1 megawatt gearbox used to be possibly 5 times bigger than the current size of the gearbox right now. So possibly from an oil perspective, because I'm sure a lot of O&M heads here will agree that the size of a standard 250 to 400 kilowatt gearbox used to hold around 600 to 700 liters. Now we are talking about a 3 megawatt or 4 megawatt holding only 180 to 200 liters. Now, had there been a standardization sometime back, I think we were also talking about IEC 81400, IEC 61400. Yes, there are standards in terms of the components to be used in a gearbox, or the components to be used in lubricant, or the components, etc., primarily in terms of making the maintenance easy. I think all those things, what we are trying to do is in terms of establishing a standardization is how do we make the life of a maintenance manager easy? How do we make the life of an asset owner much more easy in terms of to maintain? Possibly, I think the dream, what I personally foresee is how good can be the interchangeability of the components over a period. Maybe right now, it may be impossible. Down the line, 1 decade later, possibly it can be easy to interchange a lot of components, depending on that. Yes, standardization is certainly there going. Today, we see a lot of standardization in lubricants used in gearboxes, because IEC 61400 clearly defines what exactly are the types of, what exactly are the molecules to be used in a PO type of synthetic oil. Now, whether is it 5 years or is it 8 years or 10 years, is it all depending on the respective manufacturer of that particular product. Certainly, yes, standardization is an aspiring dream, but possibly I feel the moment I talk about standardization, then we need to, lay down the specifications in detail very clearly. But I think certainly it will be a hurdle for innovation, because innovation has no hurdles.
I think that's a very good point, that innovation doesn't have hurdles, but also the fact that you said that sometimes standardization stifles the innovation too. Fair point. So now coming to you, Mahesh, I think the reason why I'm going to bring up this point is it was an interesting choice of word that you have used. Basically, you called as component tourism, right? So technically, whenever you launch a new product, especially for India point of view, it's a very cost-sensitive market, right? So localization is very, very key. Do you think you have any ideas, or Nordex is planning to do any ideas in the area of improving localization through innovation?
Yeah, thank you. So exactly, means we have coined the word already. It's a component tourism. We often use in our internal company discussions. Okay, so now maybe in the early stage of wind turbine industries, we started using maybe full turbine, entire turbine importing and erections. That's what we did. And for the last 3 decades, we improved a lot. Okay, now 3 of the Western OEMs using India as a manufacturing hub, and we are, Nordex is one of them, for using this India as a manufacturing hub. Okay, but if you ask honestly, means whether our supply chain is so strong enough to hold this manufacturing of India as a manufacturing hub for the wind turbine is concerned, then it's a question mark. Okay, So we still a long way to go. Okay. There are some hurdles. Okay. Means as a supply chain development as well as an engineering team, we put a lot of efforts in making an alternative component and alternative supply development. This is what we regularly doing, okay, for the India supply chain developments. Okay. Or otherwise what will happen? A simple sensor, okay, or otherwise a simple material which is coming all the way from Europe, okay, and getting assembled in India, and it is again going back to Europe for the installations. These situations we need to focus and we need to avoid. Okay. For that, we need to create a good supply chain ecosystems in India to cater this wind energy market. Okay. As of now, Indian supply chain system is best suitable for a 2 megawatt as well as a 3 megawatt platform is concerned. Now we are going forward to the 5 megawatt as well as 6 megawatt platform. So whenever you are using in India as a manufacturing hub, every company would like to do a 7 megawatt as well as 8 megawatt turbines. So going forward, we need to focus more on developing the supply chain network. Okay, we need to develop an ecosystems which can support this particular manufacturing, India as a manufacturing hub. This is what my point is.
Okay.
Thank you.
Thanks, Mahesh. I think following up to that particular point, RP, I would like to come back to you. I think the business model that was changed a couple of years back, right? Previously, the OEMs used to do all the turnkey solution. Right now, it's more of X works, right? Now, if you look at innovation, is in your company mainly looking at innovation from X-Works point of view? If everybody is working in a siloed way, are we losing the momentum of looking at levelized cost of energy in a holistic way?
See, as you rightly said, now entire scope has changed. Now majority of OEMs is focused on X-Works, right? You're right. Again, cost of energy or maybe how we can able to cost focus, again comes from the volumes. Now, yes, earlier, as you rightly said, OEMs is doing end-to-end, all this one. Yes, they have a control, they can pre-plan this, plan what depends on capacity, depends on orders, they can pre-plan, they can do it. But unfortunately, what are the reasons of the policy and tariffs, whatever this one, without going to detail. Now going to the IPPs, owners are taking care of that. That is maybe depends on, this is possible, even still with the IPPs, depends on the bigger IPPs. If they have a doing like a 1 gigawatt or 2 gigawatt, 3 gigawatt, yes, they can also, irrespective of, this is good by doing that because they're irrespective of different OEM they're coming with. Because not only one OEM, they're coming with a different OEM. Definitely can create as a OEM also, IPPs also have a separate team on engineering so that how can able to optimize the logistics. Because in the same different OEM turbines, then how can they can make it with the same trailers or maybe some modification of the logistic point of view. They can give the, of course, we are also getting a lot of ideas to the, from IPPs, okay, why don't you change the fixes of this one? I'm talking about logistics point of view. So that they can able to standardize for the across all OEMs. So that they can make it, so then there we can get the, because logistics one of the major costs on the BOP point of view. So then they're going to be reduce the cost. That's what they can do it.
Okay, thank you so much. I think there's a little bit of contradictory. At one point of time, standardization steps innovation. You feel that there should be a standardization in certain aspects. I think that's the key message, right? It
standardization is certainly a starting point. You know, I think it's a long journey because certainly I think as we all agreed, fundamentally I think a lot of innovation also starts with, you know, how best can I optimize the resources, which is possible through standardized thinking. But having said that, you know, what are all my existing resources? For example, let's say, you know, if I want to create, you know, manufacture a component, you know, same is the case with, for example, let's say either Windergy, like as a component manufacturer. So, because way back, you know, are we looking at cast steels or case hardened steels? So depending on the component, again, keeping the end objective in mind, is the end objective now today, since we are all talking about clean energy, I think considering those things possibly, I think we'll have to see what are all those possible options, which I can actually carefully choose and select, you know, as a standard process, because certainly, you know, we are not supposed to use any carcinogenic material or something, you know, which is toxic in nature when we are producing any fuels or lubricants in our case. So that's, certainly there are some standards available, and hence the journey should start from a standardization.
Adding to what Shivi's mentioned earlier, see, standardization, yes, of course, a good point. Of course, it is good for across the OEMs. But if you ask me, yes, all low hanging, like as you mentioned, like lubrications or maybe oils or maybe few small like pitch motors or something, they can definitely, of course, all are doing now, all IPPs now, they're doing the, managing the, across this one, they're already started. But coming to the key components, like a gearbox, or maybe you can say blades, or maybe you can say, these are the, definitely each OEM have their own IP. And they're definitely they have, if they want to be performance, this is because this is market driven by the competition, and they have to see how best performance turbine is going to be do it. So they have their own specialization. They have to build the best technology in best turbine. So that time it's a difficult standardization, and these two become again contradictory.
It's a fair point. So I'll come back to Alfonso. I think I just want to hear your perspective on innovation, right? So you look at a lot of your products in the European market or probably in the Western world, and when you look at your products for the India-specific market, is it heavily innovation done on the cost out, or is it something that you guys look at in a different way? Just want to hear your thoughts.
Hello? Okay. Yeah, thank you for raising this question in general. For sure, innovation is not a self-driven thing. So innovation is also always a kind of trying to give an answer to requests of our customer, of the development of the needs inside of the market, and you want to adopt to that. And you want to make up your mind, what is your contribution to the improving the needs of your customer? Yeah, one important topic really is something where you want to improve. Yeah, we already have talked about the apex itself. Yeah, so this is a very important topic which is always discussed in negotiations, and our contribution to that is that we look for these kind of innovations where we really can do our job, house intern. For sure, also we think about standardization, what already have been discussed and yeah, spoken to. Standardization is for sure something you have to think about, but you don't have to do this just yeah, to do creating standards. Standardization also is providing costs. Yeah, you cannot create a standard without doing a kind of over-dimensioning, exceeding the needs of the single solution itself. Yeah? So you always have to make up your mind what is the cost of this standardization and what is the benefit. And this needs to be at least in balance. Yeah? Usually you expect and want to have a benefit out of that. Yeah? So it does not have always to be only on the cost side, but it can also be having standard solutions. It does not have to be ended out in a standard component which is used always in the same way. It can also be a standardization of providing a solution to the customer where you already have gained experience, yeah, where you can provide by that reliability, and that is something probably we address from our side in creating guidelines for our appliers, for our internal staff, that we ensure a certain quality in our product, that you can rely on that, where we have gained over the years experience, and that is the way how we want to get this adopted.
I think that's a very, very interesting insight. I mean, Mahesh, coming to the same point in a different way, there should be really a good collaboration between the OEM and the suppliers, right? Now, one of the things that we see is there's a lot of push to extend the life of a particular component, right? I think because that helps the turbine to be operating at a much longevity is much higher, so it can help push the debt much longer and it can give a better cash flow to the customers, right? So what are your views on that? I mean, is there an internal push between the suppliers and the OEMs to work on a common platform in terms of certain innovations that you are looking in terms of improving the longevity of these components?
Yeah, exactly. Means the way we operate in this wind turbine component development as well as the design of the wind turbine, it's changed a lot. Okay. In earlier conditions, we make specifications for some gearboxes or something for the load envelope and everything. We hand over to the gearbox supplier and ask them to manufacture it. Okay. Now we normally go for this development cycle. It's long. Okay, and we do have common forums wherein we hand in hand collaborate with the customers as well as, suppliers as well as OEM, and we do this development together. It is not a silos, no more silos now, okay. So we are doing the bigger components, like key components, we are doing it together, okay. Means some of the sensors and other things we go for the off the shelf and we will use it as it is, okay. For the gearbox is concerned and some other critical components is concerned, the pitch system is concerned, we always go for a collaborative approach, okay. So this will ease us with maybe a software sharing. Even we will do the analysis and they will also do the analysis on their softwares. We do evaluate this together and we come up with a solution. This is an optimal design for our particular machine. Then we go for a design life. Normally earlier the design life requirement was 20 years. Nowadays people are asking for 30 years and we are going towards 40 years of a lifetime. Okay. So for that also, as a supplier as well as OEM, we work together in a very, very stringent way to find out right solutions. Means you cannot, you can get a 40 years gearbox lifetime also, but whether are you ready to pay for it? Okay. That's a key question. Okay. So exactly. We need to, yeah, exactly.
Exactly. I'm just about adding to that. See, in generally we'll give the 20 years as the design life. Okay. Nowadays, of course, a lot of customers asking for 25 years, few customers asking for 30 years also. What generally as a OEM, what we'll do, we'll of course, as you rightly mentioned, within the design envelope, what are the components will be went for 25 years, 30 years. That will check. Okay. Few components may pass the even 25 years or 30 years also. Few components may not pass. Then what our engineering and our technology team put all the efforts to be how we can improve that life of this one. Yes, if you ask me, solution is there, yes, is there. But again, as you rightly said, considering the present, not only India, across the globe, again, cost sensitive. If you go with the longer life, then again, it will going to be, again, cost is going to be increased. So that is again, vice versa, innovation versus this one.
I think coming to that point, Shiva, if you can give me some insights in terms of the fact that I've always heard that you can create the greatest product, but if the product is not launched on time, it is as good as an obsolete product. So how do you balance you and your organization between innovation and bringing the product to the market?
Yeah, thank you, Chair. I think Mahesh used an interesting word, primarily in terms of co-development, or I think so. We also work something called co-engineering. It's a similar concept, but I think there's a famous saying in English. This the strength of the chain depends on the weakest link. So while we may do great amount of innovation, we may do great amount of research, but is it really holistic? Now, when we look into this, for example, many a times, often in my own experience as a tribologist, I see in the bigger scheme of things, sometimes we may ignore something very minor one like the filters or the type of elastomers used or the type of hoses used, the type of breathers used. So, and what exactly are these contributing to? For example, now, I think we are talking about 20 years to 40 years of life of a gearbox. So when we are talking about 40 years or 30 years of a life of a whole component, are we ensuring that we have the right kind of, right kind of auxiliary equipment? When I'm talking about auxiliaries, it's filters or breathers or hoses or oils and a lot of these things. Now, that's where the whole thing comes very important is in terms of how do we ensure that we develop the right kind of component, we do the right kind of innovation to extend the life of all these things also. So when we're talking about this, maybe 10 years back, 3 to 4 years of oil life in a gearbox used to be wow. No, I think it used to be considered to be very good. Now we are talking about 10 years becoming a new normal. Likewise, the cleanliness standards were never there earlier. So there was no definition of cleanliness. But after 2018, there was this very strict cleanliness of ISO 4406 cleanliness standards. It means that type of oil used in a gearbox need to be blank by 14 by 11. It means we are particularly monitoring 4 micron to 14 micron particle count, which is a specification again, which is a standard. Now, it means for me to reach such standard, it means there is a lot of innovation needs to be in pipeline, which means that I need to collaborate with the gearbox partners, I need to collaborate with asset owners, I need to work with IPPs, etc. in terms of, in the whole schema, in the scheme of things, the molecule, what we are innovating, is it going to give the desired results, which is governed by IEC 61400? I think that's where we need to work. There need to be strong collaboration across OEMs, industry partners, industry bodies, etc. So again, we work with ISO, we work with ASTMs, we work with a lot of independent bodies, including FZG, institutes, etc., to work on a lot of these reliability standards. I think that's, again, why are we discussing all these things? The fundamental objective is certainly, yes, innovation certainly brings the cost down. So from a fundamental life of 3 years, we are straight away increasing the life of oil at least by 4 to 5 times. It means we are not only saving the cost of oil, but the cost of maintenance, the cost of productivity, the productivity loss, again, the cost of replacement times, the cost of shutdowns, and more or less the cost of stoppages and all those things. I think that's where the whole thing comes in play. I think I believe that.
Thanks, Shiva. I just want to hear from your perspective, Alfonso, on the same thing, because we discussed prior to the conversation that in the time to get to the market is very, very crucial. So what are your thoughts on that?
Yeah, I think everybody is aware that time to market is a very, very important topic. So as long as you are the first in getting access to this market, you have the chance to get a bigger share of this market. And this supports your business in that way that you also can make money out of that. And you can also let's say, distribute your cost to a higher quantity of your products. And from that point, I think it is really very important that you do the utmost to have a good performance, have your product right away available. And for sure, there are different approaches to get to this target. Yeah. So one solution can be that you have you use already existing products, take that as a base for further development, adopting these to the new application. That is something which is well known, particularly for the Indian market, as long as here usually not the biggest turbine sizes are put on site. I think there's always already solutions available which have been developed, where you also have the advantage that you can select those products who have a good reliability, a good reputation, by decreasing, once again, also again in future, the OPEX costs. Yeah, so that is something, some aspects which also can be considered by that.
Okay, great point. So Mahesh, I would like to come back to you. Probably I would like to go to each one of you separately with the same question. I think we discussed quite extensively that if you look at it from an asset owner point of view, right? I mean, you're giving the longevity for 25, 30 years, and the biggest constraint right now is whether the existence of that particular OEM or supplier will exist in the remaining life of that particular asset. Now, given that, how much focus and emphasis is being done by a particular supplier or an OEM to look at from that perspective? Because it's a challenge, right? I mean, you always think that you will be there, but given the financial circumstances, how the market is evolving, the energy transition is happening, is there a real collaboration between different OEMs to ensure that this is taken at a priority, because this is the biggest pain point of an asset owner at this point of time?
Yeah, it's a very difficult question to answer. Yeah. You put me in a fix. The point here is maybe each and every turbine manufacturer, they have their own design strategy as well as a design philosophy they follow actually. Okay. So if you write one-line answer, no, there is no collaboration which is happening to ease out the asset owner's pain point. Okay, so we wanted to make ourselves USP that maybe we are specialized in something, we are specialized in something. So somehow we need to differentiate ourselves from the competitors. Okay, we need to be stand ourselves in a better way that we may use that as a marketing statics. Okay. And we say that, okay, this technology we are using, which will reduce the noise level, which will get you a more yield for the same soft area. Okay. So, and these are all the turbines we are using in anti-icing systems, which will work in your northern hemisphere without any problem, without any stoppage. And for that, each and every supplier, as well as each and every OEMs, they are going for the patents. Okay. And maybe if at all, whatever your question is, means if we are going for a collaborations kind of thing, which is only possible, maybe I'm very premature to announce it, only possible in the mobile charger, not with the wind turbines, I believe so. Yeah, of course, yes, it is possible that on the BOP side, exactly possible on the BOP side, maybe the ME transformers as well as that structures and the lines and conductors, out of the turbine, whatever you want to standardize, you can standardize it. But inside turbine, it's my property. It's
a fair point, but I just
maybe just to have a counter view. For example, while we're talking about mobile chargers, now in the component industry, for example, 15 to 20 years back, we used to face this question: hey, look, I'm using some kind of peculiar molecule in a gearbox. It is not supposed to touch, neither you are not supposed to know. That used to be the statement of a lot of, but now things are changed, right? Now, the asset owner or the OEM is supposed to know what is the molecule, what is the kind of additive, what is the kind of base stock I'm using if I'm supplying a lubricant. So it means there is some amount of standardization which already took place for the larger goal of innovation, for the larger goal of achieving the productivity. Now, it means that possibly, I think going back to the moderator's question, possibly 20 years back, if at all, if I have to, if that particular oil is not available or that particular molecule is not available, what are the best options for me to have to ensure a compatibility, backward compatibility of the same thing? Let's say, you are driving your car on a highway, you fill your gasoline or petrol at one petrol station, you go to the other place, you are having a similar kind of petrol from a different supplier. Now, it means there is already standardization happening there. So same is a case which is already happening in case of lubricants. To a great extent, I will not say it's already there. Possibly we may see this happening in other areas in terms of hoses, in terms of filters, maybe in terms of breathers, over a period of time. Slowly we will reach to the final destination. Of course, it is not easy right now. It's not happening immediately. But possibly, I think since we are aspiring for 20 years, etc., I'm sure we are going to aspire that. Again, I'll give you an interesting anecdote. In fact, 4 years back, just to give a perspective, Shell used to produce about 1.7 gigatons per annum of emissions, the kind of fuel or lubricants what we produce, across the globe. And by 2050, we wanted to make it zero. Is it possible? Theoretically, no. But then there's a very, very clear roadmap in terms of what are all my products related to the industry, particularly wind industry. And the reason why we have launched a product called Omala S5 Wind is we have labeled it as a carbon neutral product. It means this product is helping you to compensate or subside the CO2 emissions, because the whole objective why somebody is installing a wind turbine is they wanted to produce clean energy. So if I'm giving a lubricant which is giving CO2, it means I'm contradicting his original aspiration. So we wanted to create a CO2 carbon neutral based type of lubricant which is compensating the CO2 emissions. The only simple possibility is I need to increase the life of the oil. I need to increase, I need to make it easily disposable. I need to make it, biodegradable over a period of time. I think the moment I achieve that, it means that I'm contributing to the larger aspiration. So if you're asking me, is there a standardization? No, as of now. Maybe 10 years later, we may achieve that.
Yeah, so just coming to you, RPV, I think I just want to make sure that you address that, because I just heard from a European OEM point of view, I just want to hear from your OEM perspective. This is really important, right, at this point of time, because we are going through that energy transition and the amount of assets that are going to come online in the next few years, they should be serviceable, right, even if you exist or you don't exist. So how are you going to address that challenge through innovation at this point of time? Because otherwise it's going back to basics and then again re-engineering the entire thing, or some of these assets can be left stranded pretty much.
Yeah, see, serviceability point of view, I can say is not a big challenge. Serviceable point of view. I mean, more of a purely on the volume point of view. See, because technologies exist, because for example, we are talking about in India, we have only 2 megawatt and 3 megawatt platform. But across the globe, we have we have a 4 megawatt and 5 megawatt and 6 megawatt across there. So serviceability point of view means, I mean, to make the volume, make it easy, yes, it can be done. But coming to the question of standardization, see, as both I hear with the both, yes, maybe we can do it up to some extent. You can say, like as you mentioned, like consumables and all, we can definitely do. If you percentage wise, if whatever said and done, we can do only maximum 30%. Maybe you can see we can do the standardization. Whatever you can say low hanging, which is common for across all the OEMs, that definitely. And one more thing I want to say, whether OEMs, answer to your question, nowadays lot of individual ISPs are there. See, a lot of, because few OEMs or maybe this one, or IPPs himself, they want to do the operate themselves. Okay. Then lot of few individual ISPs are coming up. So naturally, they're going to be take care of that across all the OEMs. What can be standardized? That is already started. Even in now also started. So they are already working in towards that direction. But already, as I mentioned, key components. That is difficult to make it because each OEM want to have their own specialization. They want to compete and make the best turbine, best performance turbine, and best cost of energy turbine. So that is the bigger challenge.
That's a good point. Alphonse, I think we talked a lot about on onshore wind. I just want to bring up the perspective of your perspective of offshore wind on a gearbox, right? I mean, imagine the number of failures previously the gearbox used to have in the 90s and early 2000s versus where we are today. What is the biggest lesson for us? Because if you look at from an India point of view, I think we do not have a complete ecosystem as what the ecosystem that exists in the North Sea because of the oil and gas industry that is out there. So I think we need to have a robust design and robust ability to ensure that we do not need to go out to the sea and service as many times as possible. So what is your view from the gearbox manufacturing point of view for India specific for offshore industry?
Yeah, that is really interesting. So what we have seen in the past, it was possible to use same products in onshore and offshore. So the sizes have not been deviating in this amount. What we see in India now is that the mean power rating of a turbine is increasing, yes, but it is not increasing as fast as in other regions worldwide. So especially if you are looking to the offshore, there you can see that turbine sizes are significantly getting bigger due to the effort erecting these turbines in the sea. Yeah? So the cost for these erections themselves is so high that it makes sense to go for a big turbine because the difference erecting a small turbine to a big turbine is not that big. And that leads to a development that for sure the turbine sizes will have to be developed separately if you're looking particularly to India for the onshore market than compared to the offshore market. So you need different solutions therefore. Yeah? And probably also the needs need to be adopted. Even for the offshore, OPEX will become even a more severe topic. Reliability will become even a more reliable topic because the operating cost and maintenance cost will impact the overall costs at all, more significantly than in onshore.
Yeah, thank you so much. I think we are running out of time, so I'll give my final thoughts in terms of the offshore industry as well. I think I heard from most of the OEMs, they are ready with the product. I think it's basically comes down to what is the price per unit at the end of the day. Having said that, I think the significant challenge for innovation will be beyond turbine, I think for offshore industry. I think that is where a lot of stakeholders needs to come together and work out a strategy in terms of ports, in terms of logistics, in terms of, the human power, right? I mean, the human capital is also very, very important. Do we have enough existing human capital who have got that knowledge and the ecosystem to build around that? Thanks everyone for making sure that we have a wonderful conversation. Hopefully the audience had a good insight into it. I really appreciate all the panelists for giving us an opportunity. Thank you. Jai Hind.
Thank you.
Thank you.
And
Thank you.
may I request Mr. Byreddy to kindly present the mementos to the speakers. Thanking Mr. R.P.V. Prasad. Thanking Mr. Mahesh Moni. Thank you, Mr. Sivashankar Kasturi. Appreciation to Mr. Alphonse Boeing. And inviting Mr. K. Bharati, our Executive Committee member of IWGMA, to kindly present the memento, thanking our moderator, Dr. Chakradhar Byreddy. May I request, gentlemen, all of you for a group photograph?